modifying the OEM battery pack junction board, this guy right here, to use Linsight. It doesn't require any permanent changes. It does require a few additional parts. It requires a 1-inch spacer for an M4 bolt. Requires an M4 by 45 bolt with an M4 washer on it. Metric. And we're going to need one more M4 washer. We'll see where that goes. We also need the 4 leads we're going to be putting on. These are 4-gauge wire. It's ultra flex. You're going to want that nice flexibility. And then they have various angles on them, which we'll talk about for the eyelets. So we'll go through and look at the guys, but first we need to open these up a bit. Where the tools we're going to need a 12mm. I have a 12mm with an extension, just a little breaker bar. We're going to need a 10mm. We're going to need a Phillips head, and you might find a flathead convenient for the following 2 things. So the flathead we're going to use to take these covers off. There's a plastic tab here. There's another one here that you push in. And we can reuse these, and I'll show you how later. It does require modification. I don't plan on using them at all. But if you want to, I'll show you the 2 mods later that you gotta do. So I'm undoing a couple more tabs here. Probably most of y'all have done this before. You're gonna want to push. Well, let's get it off first. Usually there's nothing stuck there. Okay, so you're gonna want to push these guys out as well to get this little ground lead off. This guy sets aside. If for some reason you still have the gray things in here, even though you've already disconnected this from your pack, you'll want to take those off. And the first thing we're going to do is we're going to look at what we need to change, and then we'll change it real fast. So we're going to add, we have this fuse section which comes here, it goes to this breaker which is right in the middle of the pack. So your pack actually comes in half right here when you turn the switch off. So half the hat pack is on one side and half is on the other. So what we're going to do first is get rid of this bar. We're going to get rid of this bar as well, and we're going to install the leads there, and that'll be 2 of the 4 leads we install. The other 2 leads are going to be a little more work. We're going to install the positive lead. It's going to come through here, and we also need to switch the current sensor around. And we're going to install the negative lead, which is actually going to connect here and then run down there. So this wire will stay. These other 3 are going to go away. So this will go away, that goes away, that goes away. We'll have leads there instead. So let's do the fuse section first. One thing I'll mention, I'm not going to put them on now, but they definitely need to be, is I have this continuous covered, it's not split cable protector, and this will keep any nicks from going through your insulation on your cable. So you'll take your cable and drop them in there. I'll do it on maybe one of them, but the other ones, they'll just stay without it for now. So the first thing we're going to do is we're going to loosen the Phillips. It's right here. Now I've already loosened this. This is going to be really tight, and when you reinstall it, you'll want to make it really tight. For this video, I've kind of left everything loose because you really got to get in there sometimes. So this guy's going to come up. You're going to keep this screw here. This piece we won't be using, so you'll just keep it. And we're going to install a lead. Now, this will have leads on the end that screw onto the actual battery posts, but I'm not sure how long they need to be yet, so I've just made them a little extra long. So this right here is an eyelet that we're going to screw on, and we've got 4-gauge wire, 4-gauge crimp. So this guy will throw in, and here we can throw the first guy in our insulation protector. So I'm just kind of weaving that in there. So we'll just slide this all the way up to here. Now this is a kind of a tight fit, so it is possible you aren't going to be able to go all the way up, but we'll try. Surprised I didn't try before starting, but so this guy's going to go underneath here and go just like that. We'll take our screw like so, and we get it all lined up, it'll just screw in. And again, I mentioned that if there's kind of an angle, so if you can't get it to fit, you'll want to pull this guy back, but there it goes there. And again, you want to make that real tight. I'm going to leave it a little loose for now. So there's our first connection, and this is going to go just where the other guy came out, right there. So we'll just stick it through like that. And there we go. So there's our first guy. Here's the ground that goes to the DC-DC. You'll notice that it already has the red overprotector on it. So the next thing we're going to do is we got to replace this guy. So we've got the battery current that comes in, goes through the switch, comes through the fuse. This is the main fuse. So if you blow the main fuse out, here, there it is. So again, this is going to be really tight, but I've left it loose here just for the video. You do need to undo both bolts. Even though we're only taking this one off, you can't remove that guy without first removing the fuse, because the bus bar actually sits underneath the Littell fuse. So we'll lift the fuse up. This guy's going to come off. We don't need that either. You can set it aside. We're going to use another cable here. You notice this one's not bent 90 degrees. And we'll just, again, you'll want to stick it in the protective cover, just so in transit, if it gets any nicks, they're not in the cable. And then we'll stick this guy back through. Like that. Take our 12mm, start it up, and we'll start the other one first. Like that. See why this isn't lined up. Okay. There we go. Okay. So there's number 2. Again, I want to make it tight. I'll leave them kind of loose for now. Alright. So there's 2 out of 4. Next we're going to do the negative lead. Now on the negative lead here, we're going to leave this guy. There's no good place to connect the negative, and you see we have these 2 negatives here. We got a screw post there and a screw post there. So theoretically we could take this negative off and we could reattach both this guy and the caps. This is the DC-DC negative and the cap negative here. We could lengthen them and attach there, but it doesn't really matter to leave the negative lead there, so we're just going to leave it there. Negative lead. Don't be fooled, the eyelet on the negative lead is smaller than the other 2. The diameter of the bolt and the screw here is much larger, whereas this is a 10mm bolt and it's smaller. So we're going to, for the negative, again, we'll want to put the insulation on it, but the negative is just going to go underneath here. It's going to go around there like that, and then we'll just kind of screw it back on there for now. When you eventually hook up the IGBIT section, the power delivery unit, that will also go on there as well. This guy is going to weave just right next to the existing lead, like that. And again, you'll have the black cover on it. So there are 3 of the 4 leads, like that. And we're done with this section over here. Remember, this wire was connected to the actual DC-DC, so this is the ground point for the IMA systems. This is where the body ground hooks up, and it just goes to these caps so that you have a ground reference. So we're done over here, as I mentioned. You'll want to make sure everything is tight. And as I mentioned before, this guy no longer fits on here, and the reason it doesn't fit on is there's some interference right here. So if you want this to go on, you want to cut this here, cut it there, and then it'll just snap right on. Before there was a bus bar that went there, now that guy's there. So we can try it. I haven't tried it yet, but take my nippers here. Got a couple pairs, so I'll probably start with this guy and just do a nice little cut like that. See the plastic cracks just a hair. Now we know. So you'll want to do this guy first, and that way the plastic won't crack. So we've cut that off. So now this guy should snap right on. Remember to push this tab in, and there it is. So, yep, we can put this back on. It protects the bus bar over here so you don't contact it either here or over here. The fuse section is going to be a similar story, but just more cutting during story time. This entire piece here is now in the way. We don't really need it, so we're going to cut it off as well. And I'm going to again take my nipper here. And, oh, that's not going to work. I'm just going to have to cut it, I guess, here. This is all untested, so I guess we could just eat up there until we get to it. Yeah, let's do that. That's probably easier. So there's 2, and that'll be flush if it works. Yeah. So we've cut 3 times off now. We cut the whole tab. And does it fit? It fits. Cool. So you can keep the fuse protected there. That's neat. That worked as easily as I thought it would. Next up, the positive terminal is a much smaller spade lug. So this is actually the smallest spade lug I could find, and it's not actually 4 gauge, it's 6 gauge. But I was able to get the 4 gauge to fit just by finessing it, and then I used the standard crimp channel lock to crimp it. This is going to go here where this bus bar is, but we got to do some things first. So the OEM system has 2 current sensors. It has this battery current sensor, which is very accurate. It is a plus or minus, so it's bipolar, and when you have 0 amps, it just generates 0 volts. So it's actually a current output, so the current that it outputs is directly proportional to the current going through it. I think it's 25 microamps per amp. I forget, doesn't matter. I was going to use it, but it requires me to have a bipolar plus or minus 15 volt supply. So I have 12 volts, so whatever, I was going to use that. Minus, you know, it's all on the Rev A PCB, but it's a headache to use. And ultimately, it required a choke converter to get my 15 to minus 15. It ultimately required a true bipolar ADC, which I didn't want to add, and then when I dropped my microprocessor down, I couldn't add it because I didn't have any open serial buses, so I couldn't talk to the ADC. So ultimately, for nickel metal hydride, you do need to be very accurate for the current in and the current out, because the resting battery voltage has very little influence on what the state of charge is. Lithium is quite different in that the resting battery voltage is a much more accurate indicator of the actual state of charge. So what that means is ultimately we're going to go to this less accurate current sensor. Now the position that it's in right now, this is a unipolar current sensor. It's from 0 to 5 volts. So when you turn it on, when you first turn the car on, you have to see what the sensor is outputting, assuming that there's 0 amps here. So after you've charged the system up and the DC-DC is off, you have to actually measure here and say, okay, this is 0 amps, and so that could be 2.5 volts or 2.6 volts or 2.4 volts, and it could change over time. So it is going to be less accurate. Now, fortunately, there are things we can do. For example, whenever we turn the engine off and the engine is not spinning, we can turn the DC-DC off too, and then we can recalibrate. So say every time you come to an auto stop, we'll recal. At the end of the day, we're accumulating charge, so we're integrating the charge consumed or delivered to the battery. If we're off a little bit, we'll catch that with the voltage, so we don't really need to be that accurate. So what we're going to do, the OEM system, the battery current sensor is with the BCM. Now, we don't have the BCM, the OEM BCM on the new version, and we can't drive both sensors because, one, we don't have enough pins on our microcontroller, but two, the wiring harness does not actually mate directly. So this battery current sensor, which is right here, does not connect to the MCM. So we're reusing the MCM connector stuff so that we don't have to cut the wiring harness. We can only use one current sensor, so we can either use this one or that one. They both share the same plug, although the wiring is different. Long story short, we need to move this current sensor over there because we want to monitor the battery current. Now what is this current sensor doing? This is measuring the current that is consumed by both the DC-DC and the battery. So if the DC-DC is consuming 5 amps, say the DC is consuming 5 amps and the engine, we're putting 10 amps into the engine, the battery current sensor will correctly measure 15 amps, whereas this guy's only going to measure the 10 amps. So the computer subtracts the 15 amps here from 10 amps here. It knows the DC-DC is consuming 5 amps. We ultimately don't really care. We don't care how much the motor delivery unit is consuming, because we know the DC-DC current is going to be relatively low. At 50 amps on the DC output, it's only 5 amps on the input, so I could really care less if I'm pulling 105 or 110 amps here. We also have the 3-phase current sensors still in the actual motor delivery, so we can actually measure the actual sinusoidal current being delivered. So long story short, we're going to move this guy to here. It's fairly easy. To do it, we're going to need an M4x45 I mentioned earlier, a 1-inch spacer, and then another washer. So let's get to it. You know, we did the first 3, it was real fast, so it makes sense that the last one is going to take a while. I'm going to just kind of start. The first thing I'm going to do is I'm going to take this bus bar off. To do that, I need to remove this fuse, this current sensor, and then these bolts here. So we'll grab our 10 millimeter here. We're going to remove that guy. And then we're going to remove this fuse. Now again, I've loosened this guy. These guys are going to be super tight, and they should be super tight when you're done with them. Don't leave them as loose as I'm leaving them here for this video. So there's that guy. Again, we got to take both sides off because the bus bars reside underneath the fuses. So there's that guy. We'll just set it aside there for now. This guy's got to come off. Again, this is going to be really tight, so when you push down, you want to push real hard, because the Phillips, by design, cams out, and you don't want to cam it out because it'll ruin the screw head. Gonna take that guy off. And then the last thing we do is we need to remove these 2 screws here from this current sensor. So there's that guy. The wire kind of got in the way. Okay, so this should all pick up and out now. You can kind of unwind that. Now the bus bar here is going to just go like that. We are going to reuse that, so just kind of set it aside. These screws, we won't be putting anything back here, so you don't really need to. That's annoying. There we go. Okay, so we're gonna leave this guy plugged in just for completion. Now we need to remove the actual bracket. That's also not going back on, so look at all this weight you're taking out of the car. So these screws won't go back. The 2 bronze colored screws we were just looking at won't go back. The bracket itself won't go back. So we'll just leave that guy there. Now the next thing we need to do is we need to remove the battery current sensor as well. And so to do that, we need to remove this screw, that screw, these 2 screws, and then we'll take this bus bar off. This is where the positive lead is ultimately going to route. Before we do that, we're going to want to go to the back side here and push the tabs here so that we can remove that. So that's again where the flathead can be useful. We're going to be removing this battery current sensor. So if you look over here, if you push on the tabs, I just pick a side and push it, and then I push another side, and typically it'll push out, but sometimes you gotta push on the top and then on the bottom as well, but that's basically it. Now we also need to remove this tab here. I have a hard time seeing it right now, but I think they ride on top. I might have to shine a flashlight in there to see. That would require me to find another flashlight. It's cheap. Yeah, okay. So I push the 2 little tabs there. That's going to get our battery sensor ready to remove. The fuse fell out. You probably just want to take that off to begin with. Still in frame. Good. So this guy's out now. So what we got to do, we got to remove the current sensor. We won't be reusing the screws, but we will be reusing the one of the screw holes. So we're going to take this off like that. A couple more things to remove. This guy is really difficult to loosen. because it's just kind of free floating here, and it's going to be really tight. So if you can, if you have problems with it, certainly don't remove that screw first. But if you have problems loosening it, you can grab it with a wrench. I haven't needed to do that, but it's kind of a, you know, maybe some people will. Again, this screw is going to be exceedingly tight, so push down super hard on it so you don't strip it out. You're breaking a copper bond that's been on there for 10 years. So we removed all this junk now. We're going to pull this guy out. We're not reusing this bar. We're getting rid of the awesome current sensor. Unfortunately, I love it. I wish I could have used it, but it just didn't work. So what do we do now? We need that to go there. So it actually just barely fits, which is really cool. So if you take it, leave it plugged in, you can't plug it in or unplug it once it's down here. And watch what I do here. I'm going to slide it down here. There's a tab here. I'm going to slide it just by that tab and then rotate it up just like that. And it fits just perfectly. So because it doesn't fit on the bottom, that's where the M4x45 and the 1-inch spacer comes in. So we're going to do the exact same thing we just did. And then the spacer is going to keep this guy from going all the way down. So I'm just kind of screwing it in now. Because this is a metric bolt, because it's a Japanese car, you'll need your, what is that, a 3mm Allen? We're going to basically tighten this guy up. Now, I've looked at this. It doesn't look like it's going to rattle. If it does, we can put a little piece of felt right here. That's really the only spot it would rattle. You might get it right there as well, but I don't think it's going to be an issue in the car. So I tighten that up a little bit. There's our current sensor. And then, you know, just kind of pamper that cable a bit so that it's nice and clean. So now what do we got to do? We got to put the one bus bar we took off back. Notice there's not going to be anything there. Like as I mentioned earlier, we're going to lose the ability to tell how much current the DC-DC converter is consuming. Note that the DC-DC converter, this is something interesting I realized, when the DC-DC converter charges the 12-volt battery, the current sensor for the 12-volt rail actually misses that. So that current is not measured. So just so you know. So we're putting this fuse back here. There's one. There's two. There's your 12mm here to tighten it. Let's see if this video can come in under half an hour. We're at 22 minutes or so right now. Again, tighten the heck out of those. Probably can't over tighten them. Okay, I screwed that on. I left it loose because I wanted to make sure that I had everything else lined up. So put this 10mm, even though we're not screwing anything into it right now, and that way you don't have problems later on. So once you've done that, then we'll tighten that guy away. So we're kind of on the home stretch now. We've got this last connector, and I mentioned that the eyelet is quite a bit smaller. What we're going to do is we're going to drop our last wire through here, through the current sensor, which we repurposed, and Linsight takes into account that repurposing. This guy is going to go just on top like that. And then it's very, very important that you put this washer here. The eyelet size is pretty big. Now it is the same size as the OEM, but I just don't like the additional flex that we're going to be adding here because this guy is fairly malleable. I don't want to bend these lips. See how this ring eyelet is pretty close? So I think it's going to be really important to put this M4 washer on there to make the diameter just a hair smaller. Now the easiest way to wrap this up here is going to be to kind of build it in reverse. So we're going to put the two leads like that on there. Remember before, this smaller lead was connected down there to the same bus bar. There's our washer, and then here's our eyelet for our big current lead. And then we will tighten that up as well. Make sure on these eyelets that they're not crushing each other. You got plenty of room. You can bend the fuse as needed there. I'm sorry, it's not a fuse. The resistor is needed there. So once you get here, again, this guy needs to be super, super tight. You don't want that to get loose on you. So at the end of the day, we now have our 4 leads. Make sure I got that bolt on. You want to make sure everything is super tight. So let's look at now what we've done. We've modified this guy so it has 4 wires coming out of it. This is our positive. This is our negative. So this guy's going to come around and hook up to battery positive. This guy's going to go to negative. And then these 2 guys are going to go halfway in the pack. And this is, I mentioned earlier, on Linsight, you have to put it either between cells 12 and 13, or cells 24 and 25, or if you have a 48S pack. I mean, if you have a 48S pack, you should be putting it between cells 24 and 25. If you have the 36S pack, you should probably also do 24 and 25. But you could also do between cells 12 and 13. If you do it in any other position, then when you turn the switch off, it will actually damage part of the BMS on Linsight. It is repairable, but you will have to send Linsight back. Okay, so that's, again, what this guy looks like. Again, make sure all the bolts are tight. Everything looks good. So we're going to move this guy out of the way, and we'll just recap real quick the things that are not reused. So, first of all, we got the bus bars here. 3 bus bars that are not going to be reused. We're not going to reuse the rubber squids there that go in because they now have wires there. We won't be reusing the battery bracket. We also won't be reusing the good current sensor, unfortunately. I really wish that we could have used this, but it was a huge headache. And after consulting with people and books, it's actually not required in lithium. So nickel metal hydride is very important. Here it's not. We've also got a handful of screws. Those guys were mounting the current sensor there. These guys mounted this current sensor here. These guys screwed that frame to there, and I have no idea. Oh, this was the one component that we kind of moved up to here and screwed down. So yeah, you should have those parts left over. If you have more parts left over, or if you don't have these left over, do double check, because that's super high voltage, and it if you plug it in wrong, you could certainly hurt yourself. So I'm going to bring it back here. You can stop the video whenever you want. I just want to go through the path on what this junction board does now. I've already described it, but you will hook these 4 leads up as previously described. So let's look at where they're going. So this is pack negative, this is pack positive, this is the ground. So pack negative is not ground, it's not engine ground, it's not the chassis ground, and in fact it will float quite a bit all over the place. It can theoretically be, I mean, theoretically the halfway voltage of the pack here, because it's going on this capacitor bank that I showed you earlier, this is body ground, and theoretically this guy can be, 60 volts from body ground, or 100 volts from body ground. Now the difference between these two is going to be very low impedance, and it will be your battery voltage that you measure. So it's kind of a interesting concept that maybe is not completely understood on the Insight here, that the negative of the pack is not ground in any way. It's actually a floating negative. And in fact, all the way up to the 3 phases for the actual motor, there is no engine ground reference. So even in the IGBIT pre-driver, the ground reference is not there. So just kind of a fun little fact there. So we have the battery negative, not ground. We have the battery negative that comes up through here. Now this hooks up to the motor drive module. No, I'm sorry, that's the computer power delivery unit, whatever it is. The thing on the left side, the IGBIT is what I call it, the IGBIT section. That's where we're driving the 3-phase motor. So power basically primarily comes into here from the engine, or it sources out. So this then is obviously the positive. So this is pack positive. But it's not actually pack positive, it's switch pack positive. So this is pack positive right here. So this is the actual pack positive terminal. Now when you turn the car on, if this is a relay right here, it's a high current relay, But relays don't like to be switched when there's a current present. It causes them to corrode, it causes them to oxidize, and it wears them out. So what Honda does here, and this is a pretty standard thing for high voltage things, we actually have, so here's our positive, and in a steady state, this is just hooked across. So positive's hooked up to here, and sure enough, there's pack positive. But what Honda does is they have this resistor right here that lets us charge this. Now, on the other side of the box, we have a bunch of very large capacitors. Let me see if I can find one, if I have one handy. I did before. I don't know. Anyway, there's three, they're 350 volt, 1750 microfarad capacitors. So they're large. They're the size of a Coke can. And there's three of them. Charging those things up will very quickly destroy this relay. So what they do is they have a resistor here. I haven't actually measured the resistance as well because we're here learning. It is 12 ohms. So we say we have 120 volts because it'll be easy. That 12 ohm resistor is going to limit the inrush current to 10 amps. So what we do then is we turn this relay on here, which actually pulls quite a bit of power, and we turn it on, and you can see that this relay is in series, so we actually charge up. So we turn this guy on, we have this 12 ohm source resistance, whereas this is, you know, a 0 ohm, a 1 milliohm source resistance maybe. Not really sure what it is. And then we charge it up until those caps are charged, and then we hook this relay up, and then we disconnect that relay. So pretty simple. The MCM is actually monitoring the voltage here via a 0 to 5 volt pin, which is ratiometric to the voltage from 0 to 200 and whatever volts that you go up to. So that is this section right here. So over here, what's this? Well, this is just the fan. This is the battery fan there. We won't be reusing that, but I mean, so theoretically you could take this off. The battery fan is actually controlled by the BCM. Of course the BCM is not present again, and the wiring harness is not the same, whatever. So you could remove this resistor if you wanted to save the weight. I'm leaving it in there, whatever. So okay, so we've done positive, we've done the negative going back. We have, this is the DC-DC converter, so again the negative hooks up there, and then the positive just hooks up through this, I think it's a 30 amp fuse. It's a high voltage break fuse. So the voltage rating on a fuse is very important because a lot of people say, oh, 30 amp fuse, you know, it's only current that breaks it. The problem is what happens when you blow that fuse out. If you use like a 12 volt, like a SAE blade fuse, you blow it out and it'll actually sustain an arc, and it'll just keep burning because the parts are too close together, and you'll get that high voltage spark there. So these are a ceramic, like a sandglass bead fuse, and that way it will suppress that spark long before anything catches on fire. So that's kind of, in high voltage, that's there. That's again why this 100 amp fuse is much larger than, you know, if you were installing a 100 amp fuse for a 12 volt audio amplifier, for example, it would be much smaller. So yeah, that is the junction board kind of demystified. And then this circuit breaker, again, it's not even a circuit breaker, it's just a switch. There is no circuit breaking effect to it. If you exceed the current, you're just going to blow the fuse out. This switch basically cuts the pack voltage in half. So that's it. It's very clean. All of the MCM connectors will go back. So here is the drive relay. This is the pre-drive relay here, which goes up through there, and then yeah, the connector here and here goes right up to the wiring harness. This will hook right back up to the DC-DC converter. So there are no permanent changes, assuming you don't cut the plastic pieces like I did there. You know, in retrospect, I like it. So I was thinking I wouldn't be worth the effort. Current sensor here is differently purposed. So of course, if you make this modification, you can't use the OEM MCM. You'll get all kinds of issues because one, we've removed the battery current sensor, but two, the current we're going to be sensing here will be off. If the BCM were to work anyway, which it won't, you're going to get IMA errors out the wazoo, missing that current sensor. This guy is going to track 5 amps more. You know, at full load on the DC-DC, you're going to have an error there because the OEM system doesn't know what we've done here. But the Linsight system is going to work perfectly. It's going to be no problem. So that's it. That is the final, the first final video I've shot for Linsight. Hopefully we have many more coming here in the next few days, weeks, months.